Hello there. All right, let me change where I'm sharing from. No, not that. Oh, there we go. All right. Hello, everybody. Okay, so we are going to do our lesson on Module 8, Lesson 3. It is compound interest with a little bit of growth and decay in there as well. Let's just start. So I'm on page 123 of the workbook. It is in our Google Classroom if you want to print it out or look at it or have it there. We have homework tonight. The homework is workbook pages 125 and 126. So that'll be due on Tuesday when I see you. Have a nice long weekend. All right, learn the math. Example 1. Alicia invested $1,250 in a savings account that earns 1.6% annual interest compounded yearly. So important to know that that's what we started with, important to know that that's our rate, and important to know that it is compounded yearly. Let's go ahead and change this 1.6% into a decimal, right? So to make 1.6 into a decimal from a percent, we're going to move the decimal place to the left 2 places. And so that'll give us 0.016 is the decimal. For those of you who need a little practice with that, let's just do a couple others up here. So if we had 27%, now our decimal is here. We move the decimal 1 place, 2 place, so then we get 0.27 would be our decimal. And we usually lead it with a leading 0, so 0.27. What if it was a little more complicated and we had 8.75%? Same rule. We're going to move the decimal 2 places to the left, so we get 0 point, and then we need to put a 0 here to hold that place, and then the 875. We can't have 2 decimals in a number, so we don't have a second one. It just becomes 0.0875. Very nice. Yeah, so keep that handy in case you need it as a reference. Then we've got when she graduates college in 5 years, so that's going to be our time, right? How many years? 5 years. She would like to buy a saxophone. Awesome. That is pretty much what we need for our compounded interest part. But then it gets more interesting because she says the saxophone she wants costs $2,500 if it's new, but the value depreciates at a rate of 12% per year. Will she have enough money in 5 years to buy a used saxophone of this model that is 5 years old? And so then we will do a growth and decay formula for that. But let's start with our compound interest. It says to use the function A equals P times the quantity 1 plus R to the T to find the balance of Alicia's savings in 5 years. Let's make sure we note that this formula only works when compounding yearly. So if they compound once a year, then this is the formula we use. If they compound twice a year, it's a different formula. If they compound monthly, which is really a traditional sense of how interest works, so monthly, that would be a different equation as well. So we'll do that on the next problem. So then we just have to know what the A, the P, the R, and the T are, right? So we've got our A, we don't know, that's what we're looking for. Our P is our principal, or what we're starting with, right? Which in this case is 1,250. Then we've got our 1 plus, and then our rate equals, our R equals rate, which in this case is 1.16%, which is 0.016. Hopefully you can read that okay. And then our T equals time, which in this case is 5 years. All right? Then you multiply that all out. Really important that you multiply this and do the exponent before you multiply the 1,250. And then if you like, you can put the little dot in between there, right? Because it's 1,250 times whatever that works out to be inside the parentheses. And let's take a minute to make sure you know how to figure that out in your calculators. So we would go 1 plus 0.016, and then you press the equal sign, and that will end that parentheses, right? Then we're going to take that, and we're going to do the exponent to the box, because the box lets us put in our 5, because it's 5 years. And then it would be nice to end your parentheses, but if you forget, it doesn't change anything. And so inside, we would get 1.08261. It like continues, right? So you want to write down as many of those numbers as you can, or you can just leave them in the calculator and write times and then punch in 1250, which is what we need to multiply it by, equals, and that gives you the 1,353.251611. All right, but let's take a second to talk about the rounding here. So our answer was 1,353.25, and that's exactly what the book wrote, right? The book wrote 1,000, that is, oh, I'm on the wrong one, 1,353.25, beautiful. But it continues on and has this 1611. Well, we're doing money. Money should always be rounded to the pennies column, which is the hundredths column, unless the directions say differently. But we don't have anything in the directions about rounding, so we should round to the pennies. The 5 is in the pennies column. So then we're going to look to the right. It is less than 5, so we don't change anything. The 0.25 stays a 0.25. I'll show you one in a little bit where we do change and we do end up rounding up, okay? All right. So this tells us that Alicia will have $1,353.25 in 5 years, which is beautiful. All she had to do was not spend the $1,250, and she earned the extra money, the other almost $100 or just over $100. Okay, now we want to know about the price of the saxophone. So the saxophone we're going to do on an exponential formula, right? So we're going to end up with, it is V equals A times the quantity, 1 plus or minus, I'll talk about how you know when it's plus and when it's minus, R, quantity to the T. Let's make sure we know what each of those things are. Okay, so the A is the initial amount. It's what you start with, okay? The V, we could call that the value. We could always just leave it as a Y. That would work. The 1 plus or minus the R. So the R is the rate. The rate of, and now let's talk about that plus or minus. If we're using a plus sign, then it's the rate of increase. So that's when we add. Or it can be the rate of decrease. And if it's a rate of decrease, we would use the minus sign. And how you know is by the wording in the problem. So here it says, but the value depreciates at a rate of 12%. So ours is going to decrease. So we're going to use the formula with the minus sign. And that's why they have the minus here. So they did 2,500. That's the initial value of the saxophone. And then 1 minus R, they take 12%. And they put it into a decimal, right? So if we have, let me just change color. If we have 12%, right? Here's the decimal on that. We're going to move it 2 places. 0.12 is the decimal that we put in for the rate. And then to the 5th power, because we're still asking after 5 years what it will be. It's kind of like if you buy a brand new car for $30,000, 5 years later, it is not still worth $30,000. It'll be worth less because it depreciated. All right? And so her new value for the saxophone will be $1,319.33. Let's plug those in to make sure that we can get those numbers, right? So I'm going to go 1 minus 0.12, and then make sure that you either equal that or put that into parentheses. Because if you go to the fifth power here, your answer will be wrong because this exponent of 5 is only going to the 0.12. And we need it to go to the answer of 1 minus 0.12. So I'm going to see if I can just delete. Beautiful. I'm going to go equals. I get 0.88. I'm going to take that to the x to the box so that I can put in a fifth power equals. And we get 0.5277. And you're like, that's not what the book got. Well, remember that we still haven't multiplied it times the 2,500. So then we multiply times 2500, and we get 1,319.3. Oh, the book got 33, but our answer is 32. So let's talk about that. I'm going to write down that answer, 1319.329792. All right, and then let's talk about rounding. So we need to round to the pennies column. That is the hundredths place. When you're doing that, all you have to do is look to the right. And it is saying that they took a penny and cut it into 10 pieces, and we actually need 9 of them. Well, 9 of them is practically the whole penny. So we're actually going to add 1 here. And so our final answer would be 1,319.33, and then you can ignore the rest. When you learned about this, and I think around 4th grade, your teacher might have done like, look to the right. If it's 5 or more, up the score. Well, 9 is more than 5, so we add 1 to the pennies column. And that's where we get the 33 instead of the 32. And then it's a word problem, so we need a word answer. In 5 years, the saxophone will be worth $1,319.33. Alicia will have enough money to buy the saxophone because she has $1,353. So she'll still have enough for a Starbucks afterwards. All right. From here, you are supposed to pause this video and go do this problem without me. All right, welcome back. This problem says that Devin invested $800 in a savings account that earns 2.25% annual interest. Let's go ahead and start by putting that percentage into a decimal. So if I move 2 spaces, I get 0.0225. If you like the leading zero, I like it too, so that's great. All right. The interest is compounded yearly, so that means I get to use this equation that we used up before. So our yearly equation is A equals P times 1 plus R all to the T. Right? It has it written right here for us as well. But the more often you read it, the more often you see it in your handwriting, the better off you'll be. At the same time, Tammy bought a baseball signed by a famous baseball player for $500. She expects, so a little risky there, she expects the value of the baseball to increase by 25%. Ooh, that's pretty. Let's put that in a decimal. 0.25 a year. Assuming, a year means we get to use this equation, right? Assuming Tammy is correct, whose investment will be worth more in 3 years? So our T equals 3 for both of them, but our rates are different and our principals are different. And then we want to know how much more. So Devin's investment started with $800 plus, we need our decimal for the rate, 0.0225. The exponent will be to the 3rd power because it's 3 years. If you plug that into your calculator, you should get about $855.22. If you want to put your dollar sign out there, that would be great. Okay. And then we do the same for Tammy's investment. Let's see what Tammy's in. Well, Tammy only spent $500 on that baseball, and her rate is 0.25, 25%, so 0.25. still to the third power. And that's going to equal $976.56. If you're not getting that, make sure that you remember to multiply by the 500 or the 800. That was a mistake I saw a lot. And then also make sure that you are cubing the 1.0225, right? Because that's what's going to be added up inside the parentheses, and then you take that to the third power. Same thing here. This is going to be 1.25 to the third power. So make sure that you're using parentheses or adding them first. So 976 is bigger than 855, so Tammy's investment will be worth more. And then it asked us to find out how much more, and that would be $121.34 more. Yeah, it is riskier though, versus in an account that guarantees or promises to get 2.25%. The 121 is a little rougher. Currently in our economy, we are earning on a high yield savings account around 3.2%, 3.6 I've seen. I don't know if they'll last long. About a year and a half, 2 years ago, this was up at 4.6%. There were some crazy good interest rates. But things change over time. So you have to look and look around, talk to people, see what they find, make sure that the banks you use are legit, right? Okay, turning the page. All right. Sorry, let me move all my pens. Okay. So here we go. Now on this one, we're going to end up using a different formula. So I'll point it out when we get to it. Natalie deposits money into an account that pays 3.2%. Ooh, let's do our percentage right now. So move it over twice. We'll get 0.032 will be our decimal, right? So then we have annual interest, but compounded quarterly. Quarterly means that we are going to compound it 4 times a year. 4 times a year, yeah. So it actually tells us that right here. The interest compounds 4 times per year, so n is equal to 4. How much should she deposit so that the balance is $1,000 in 5 years? And people will actually use this to do like plan for retirement. If I want to have $2 million in 40 years when I want to retire, how much do I have to put in the bank today? And then if we did even more complicated calculations, we could do how much per month for the next 40 years so that you would have your 2 million or however much you think you'll need, right? All right, and then we're solving for P this time, so that's what's different. So notice we have our amount that we'll have total equals the principal, what we start with, times 1 plus the rate over n. And n is how many times we compound per year, and then all of that to the nt power. So we plug it in. So the amount she wants to have is 1,000, and we got to know when that equals P times, right? These are next to each other, so that's multiplication. 1 plus, and then 0.032 divided by 4. All of that to the 4 times 5, which will be 20, okay? Go ahead and try to put that into a calculator, right? On your iPhone, you might have a calculator. Go to the scientific one. You do that by clicking the calculator icon in the bottom left of your calculator, and you can take it from basic to scientific. And then you can divide all of that, and it's funny because they left it as 1.008 to the 20th, but a lot of people in our classes were like, why wouldn't you just do that to the 20th power? So let's do that. 1.008 to the 20th power is going to give us P times 1.172764,043. And that's all going to equal 1,000, right? Now, if you were in class, I kind of went off to the side and showed a little something. So let me do that up here. is that if we had a problem that was 15 equals 5p, how would we get the p by itself? You would divide by 5. So we have this as 5 times 5. The opposite of multiplication is division, so we would divide by 5. That fraction bar is division. We would do that to both sides. 15 divided by 5 is 3, so we get 3 equals p. But what if they mixed up the order and they did 15 equals p times 5? How would you get the p alone there? Well, it's the same thing. This is still multiplication, so we would divide by 5, we would divide by 5, and we still get 3 equals p. Well, that's what we're doing here, is we have a p, and then we have parentheses with all this complicated stuff, but we're just going to divide to both sides by that complicated stuff so that we can get the p by itself. So I know it's a lot to write, but we're going to take this side and we're going to divide by 1.172764043 because this divided by this gives us 1, and so we're just going to have p left on this side. And then what you do to one side, you have to do the other. So over here, I've got to take 1,000 and divide by 1.172764043. And then we're going to put that into our calculator. And we're going to do 1,000. Let's see, if I put it here, will that you be able to see it? 1,000 divided by 1.172764043. Oops, I did a plus. Let me delete 3. And then equals. And we get 852.684. And it keeps going. But we have to round to the pennies column, which is an 8. But the 8 doesn't matter. I have to look next door, and it's 5 or more. I up the score. So that's how we get 852.69, because we add 1 to the pennies column. So my 68 cents turns into 69 cents. Right? And that's how it works. Okay. Now, this is where you stop and you do this. I will let you know that we're going to do it in our notebook. So if you want to do this in your notebook, that would be great. All right, I'm going to set that up for us. I don't have the notebook I wanted. This will be fine. Okay, let's go. All right, so let's label it Module 8 because this is the first lesson we're doing in 8, even though it's 8.3. Today is Friday the 13th of February, and I would like to point out it's Friday the 13th, and look at our date. If we go 2 times 13, that equals 26. So fun. Such a good party trick, you guys. It's really the best. You're going to be so popular in college, pointing out these fun math things. All right. So here we go. We are in the workbook, so I do want to let us know where we got this problem. And we're on page 124. All right. And then you should have done it without me, right? That was the whole idea. So welcome back. Let's talk about Lou. So sorry. All right. So it says that Lou deposits money into an account that pays 1.9%. Ooh, 1.9% becomes 0.019 as a decimal. The annual interest rate compounded semi-annually twice per year. So that tells me right there that I need an N, and the N is going to be 2 because it's not just yearly, it's twice per year. How much should he deposit so that the balance is 850? So I want my A to be 150 at the end, and the P is the principal, and I don't know what it is. It's what we're trying to find out. And the time is 3 years. and then we just plug all of that into our formula. Our formula, when we are doing compounded more than just once a year, is A equals P times 1 plus R over N to the NT. Start plugging it in. So we get 850 equals P. That's what I want to solve for. Now, I could literally divide this all right now. Let me do it in pencil so that you can see. But I could divide right here and put the 1 plus R over N to the NT. I could do all of that right here, right now, because that's how I get the P by itself. I don't know that your brains are going to work like that yet, so I'm going to do it the old-fashioned way. But if you see it that way, go ahead and work it that way, because it'll get you the answer and it'll save you a step or two. All right, so we've got 1 plus our rate is 0.019 over twice a year to the 2 times 3 years. And then you can put that in your calculator. You can watch me do it if that is better for you. All right, so I cleared, and let's go 1 plus 0.019 divided by 2. I'm going to go equals because I didn't put a beginning parentheses. So that gives me 1.0095, but I'm going to take that to the 6th power. And I did to the 6th power by using this button right here. Now you can't see. Okay, this button right here took it to the 6th power. I press equals, and I get 1.058, all of that, right? So I get 850 equals P times 1.05837,102. And now I have to divide both sides by that. I'm not going to write it out. I'm just going to do it. So 850 divided by 1.05837, 102 equals, and it gives us 803.1210076. And that makes sense. Like, we should have put in less money, right? So if we started with $803 and we earned this percent interest for 3 years, compounded twice a year, it would get us an extra like $50, $47, right? Ms. Heathcote, this is not how we write numbers for money. You are correct, we do not. For money, we stop at the pennies place. Now keep in mind, if you work in big finance, if you work in index funds, mutual funds, things like that, I believe they do go to the next place over, to the thousands place, but we do not. We're just normal people. So we'll look at the 2, look to the right, 5 or more, up the score, 4 or less, let it rest. We're going to let it rest. So our final answer is going to be $803.12. Okay? And that is how you do those. So now we're going to jump back over to our workbook. And let's do example 3, okay? Now, example 3 is super fun. In fact, I can't wait to tell you all about it. Okay, so example 3 says, Ian deposited $400 into an account that earns 1.75%. Let's put it into a decimal, 0.0175. Annual interest compounded continuously. Okay, so, we've talked about, quarterly, semi-annually. You could do monthly. Monthly's really normal, so N would equal 12. You could do daily interest, so N would equal 365 because we have 365 days a year, right? Or N, you could do it twice a day, so N would be like 800 something or 700 something, right? You could do 3 times a day. Now you're going to be closer to 1,000. Well, some guy named Euler kept playing with that. He's like, well, what if you compounded it 1,000 times in a year? What about 10,000 times in a year? Wait. What if you compounded it 100,000 times in a year? Like, what would that look like, right? And so he realized that this number that he kept getting, even though his n was changing, the number just kept getting closer and closer and closer to like 2.71 or something. I don't even know. And so he got to name the number E after himself. So E is called Euler's number. Note that it looks like it's Euler's, but it is pronounced Euler's. Okay? So E is Euler's number, and it's 2 point something. And kind of like pi is 3.14, we're not really worried about what Euler's is because we have a button for it. So when we get there, we are going to use the shift key so that we can use things in orange. And then written in orange, we have this E to the power of a box. And so we will use that. It even has it on your iPhone in your scientific calculator, so you'll be able to use it there. It says, how much will the account be worth in 2 years? How much time will it take for the balance to reach 600? This one, how much time will it take for the balance to reach 600? We're going to work on that next week if we do it at all. And we'll do it in Desmos and be able to look at the graph from there. So we're not doing that part today. So when you have continuous compounding, this is the formula we use. So let's make a note of that. Use for continuous compounding. Thanks, Euler, for working that out for us so we didn't have to figure it out every time. So then they took the original amount, 400, times E to the rate, which was our 0.0175, times 2, because we have 2 years, and put it into your calculator and see if you can get the 14.25. I can show you how I'll do it on mine, hopefully. Okay, we do 400 times, and then I'm going to go shift, so I'm using the orange part, right? It tells the calculator, oh, I don't want the regular button, I want the shifted button. So we do shift, and notice I get my Euler's number to the, and then we're going to go, what's my rate? 0.0175 times 2, and then you can end your parentheses, equals 14.24. Right, so again, we're going to round to the pennies column. That's the hundredths column. We have a 4 in the pennies column. When I look to the right, there's a 7. So it's 5 or more. We up the score. So that 0.24 is going to become 0.25. We add 1 penny based on the 7 being most of a part of another penny. Okay? All right, that's how it works. We're not doing the second part of that problem, so we can ignore the graph. You are now going to open up your notebook and do this part with Emily, right? And again, how much time will it take for the balance to reach 1250? We're going to wait on that part. So you don't have to do that part yet, but please do up to the question mark at 4 years. All right, welcome back. So you should be in your notebook again. We're going to label this as example 3, page 124. All right, the Emily problem, right? We are going to use the function a equals p e to the rt. Right, it says Emily deposited $900. So A is what we're looking for, I guess, because P is what she's starting with. She deposited $900, so P is our 900, into an account that earns 2.1, so our rate equals 2.1%, but I need that in a decimal, so I'm going to move 2 spaces, 0.021. Annual interest compounded continuously. Continuously is what tells us that we're going to use this formula. How much will the account be worth in 4 years? Time equals 4 years. Awesome. And then we're not doing the second part of the problem yet. Okay, so we've got A equals 900 E, and then R is to the 0.021 times 4 years. And then I did see some people who were doing the E first, and that will also work. You can press the shift to the E to the power button, and then go 0.021 times 4 equals, and you'll get some number that is not the answer, that doesn't make sense, right? Like, he started with $900, why does he only have $1 now? And you then have to multiply it times the 900, because the interest is compounding on the $900 that you put in. Your answer would be different if your interest was compounding on $400 or $1 or $1 million, right? And we do equals, and we get 978.8660044. Can I just put a $sign on there and call that an answer? Absolutely not, because we round to the pennies unless we have different directions, right? So I'm rounding to the pennies, so I look to the right of the pennies. 5 or more up the score, so I'm going to add one more penny. I get $978.87 with a $sign. There you go. All right. That is what we did today, although we did have a nice talk about credit card compounding interest. So since you missed that, you should ask someone in class, see what they remember and can tell you about it. Ask a family member about it. Ask somebody else how credit cards and interest work. That would be great. Have a wonderful weekend, and we will talk again soon.